Right, let's get started with Matlab. What is it? What do we use it for? How do we get it? Well, Matlab's a programming language that's very often used by engineers and scientists, and its name derives from matrix laboratory, and that's because Matlab is well suited for high-speed vector matrix calculations. That was the original intention behind Matlab, and of course over the years and well over the decades it's grown to become useful in many more areas than that. On a personal note, I've used Matlab over the years. It's the one that has really persisted. I've used something like 9 or 10 different languages, but this is the one that I find the simplest and the quickest to give me results when trying to derive some numerical kind of outcome. One of the reasons we'll find for that is that it removes much of the technical work behind the creation of a computer program. So whereas in other languages it's necessary for us to define variables before we use them and to create some kind of rigid structure that we have to follow consistently, Matlab is far looser than that. It allows us to jump straight to writing in our equations and solving our problems. Of course, the more structured we are in our approach, the better, but it doesn't have to pose an obstacle to us. Another important aspect is that it's quite easy almost to see the equations in the code. If we use it correctly, that is, if we write the code well, we can almost see what we're intending to simulate, whereas in other languages we tend to be stuck in for loops and if-then statements that make it quite difficult to trace where we are. Right, so how do we get Matlab? You can see the Matlab website is open here, and you can get a student version of that, which is much cheaper than the professional version. You can get that in most bookshops. There are other alternatives. There's Scilab here. If you go to scilab.org, you'll find that there's a free open source version which does virtually the same thing as Matlab. There's also Octave. That's another programming language very similar to Matlab in its syntax, and you can download that from new.org software Octave. For the set of notes, we will be defaulting to Matlab. So to get started, where is Matlab? Let's pull up our Explorer and let's just go to my desktop. And on the desktop you can see among the icons the Matlab icon here, so it looks like that. Just double click on that and that will pull up Matlab for us. So let's look inside Matlab. When you open Matlab, you'll find here this set of boxes, the chief one being this one, the command window, and that's where we execute all our Matlab statements. So in the first instance, you'll find that you can execute any statement directly in the command window. So for instance, if we wanted to add two numbers together, we could just type that there, and so the result of that is shown. So Matlab's created a variable ANS, short I guess for answer, and it stored the result here. So that's the command window. That's where we execute the statements, and you see here we've used it almost like a calculator. But it's quite a lot more than that, because we can create variables in that command window. Let's say we create a equals 10 there, and so you can store in memory whatever variables you choose to create. You can see here that as I'm typing in my commands or statements, that the list of statements is growing here. So let's run that one. So b equals 10, that's stored over here. So we've got a nice command history here. You can see all the commands that we've typed in stored back here. And you can easily execute any of those. If you press the up arrow key, you can see we're scrolling through all the previous statements that I've run here. If you press the forward key, you scroll forward through that list. So that's the command history box down here. Then in the current folder, you can see all the Matlab files that we've stored. So these .m files are where we store Matlab script, and more about that a bit later. Now, the major stumbling point I find with students is something as simple as the path here. Right, we have to be in the right folder if we want to use any of the MATLAB files that we might have written. So if we try to execute this this function here, let's say we want to run test01, which is a MATLAB script that I've written, we have to be in the right folder. So that that MATLAB file is written here, that is in our current directory, so we can see that's the current path there, and we are in this folder. So if we execute that statement test01, it's going to run. So behind that is the script that creates for us this vector. So we are in the right folder, we can execute that, but if we're not in that folder, let's say we were in some other place, let's just say here we were on the root, then you see, let's say that's the current directory, and I've used the command change directory to go there. So change directory to the root, and in the root I don't have these MATLAB files. So let's look here. You can see we don't have any MATLAB files in here. If I try to run that old command test01, that's not going to work anymore. So let's go back to that path. So let's just find it here. That's under my courses folder, and here this is created around the course, the Maths 3080 course, and I think it was the Sims folder that I started. Yeah, test01, that's in the Sims folder here. So the quickest way to do it is just to copy the path from here, and I can say change directory and paste that path, or I can just copy that path or paste that path in here where it says current directory. So let's just paste that in, and you see now we're back to that folder, and now we can execute test01. That's something that very often trips students up. Something else we should be aware of is that MATLAB is well documented in its help files. I guess we're all used to the convention that the help box is the last one there, and we can access the help. But something that's more useful, I feel, is the built-in help, where if you type help and let's say there's a function ODE45. So this is one of the functions that ships with MATLAB, and we can look inside the help that's stored inside that file. So if we type help ODE45, you see here it's going to spit out a lot of text on the screen, and that explains to us how we can use this ODE45. So it gives us the syntax in which it expects us to use ODE45 with an explanation of how to use it. Right, so that's the help, and then something I've been doing which I didn't explain is use the CLC command that just clears the workspace. So clear, that just clears the screen for us. If we want to clear all the variables in memory, then we say clear all, and if we want to close any figures that might be open, we say close all. So quite often I start all my programs with the statement close all, clear all, CLC. That's usually the first line in any program I write. Now, of course, we can use MATLAB almost like a calculator. As I said before, we can execute our statements here. We can even create variables, and we can operate like that, but of course that's impractical. If we want to save our work and continue on the next day, or more importantly, if we want to create code that we can reuse, then we'll want to store all those commands in some kind of file, so that we can come back later and edit what we did or change those instructions. So to access the editor, you can click here on this edit icon, or we can just type edit in the command window. So that brings up the editor, and you can see I have some files that I was working on before that's stored down here. And now MATLAB's created for us this new file here, untitled 5. So as I said before, start off with initializing the workspace. So close all, clear all, CLC. You can see that it's numbering for us our statements. So let's create here our variables a equals 10 and b equals 20, and let's store the sum of those two in the variable c. So that's a plus b here. You can see I've been using the semicolons. The semicolons are used to suppress any output from appearing on the screen. So let's go back to the command window, and I'm just alt-tabbing back there. Oop. Okay. So if we say a equals 10 without a semicolon, then that's giving us a result on the screen, which we don't always want, right? So let's just say a equals 10, and we have the faith that MATLAB's just going to execute that, so we don't need to see anything on the screen, and that's just gone on to the next line there. So we can use the semicolon to suppress any output to the screen, and let's say we stored those values in those variables, and then we do want to see on the screen the result of that addition. So we leave the semicolon off there. Now I'm going to save all of these statements as an M file, which I can run from inside the command window. So I'm just hitting Control S to save, and of course you could have clicked here using that save icon. So let's just save this in our current workspace. So let's start a new folder for our materials. So I'm just going to delete that one. So in these video notes, I'm going to create a new folder here and save that one as Sims. And going into Sims, I'm just going to copy that as the path. So in Matlab, where are you? Okay, it's waiting for me. So here, let's save in this path, let's save that as sim 001, and you'll see it's created in the folder that we've chosen, sim 001, and it's given it the extension .m. So if we go to our command window here, you can see, well, let's switch to that folder. You see I'm in the wrong folder at the moment. So to switch to that folder, as I said before, change directory, give the path name there, and it switched there, and you can see sim 001 is stored there now. Let's just clear the screen, and then we're going to type sim 001, and you see the result of that. It stored a and b as 10 and 20 respectively, and it's created the variable c and stored the value of the result of that addition. So c equals 30. That's appeared on the screen because we haven't suppressed that output here. There's no semicolon. So if we were instead to insert that semicolon there and then save it, so just Control S to save, and then we run the sim 01. So again, I've used the up arrow, right? Escape to clear the line, up arrow just to create or to call back the last command, sim 001, and let's run that. And then you see there's no output on the screen, but we have faith that it has that the compiler has created the variables and stored the right values. So to just check that, we can type in A here, and it will return for us on the screen the value of A. We can type B and C. So it's given us the right values in the right variables. So those are the very basic elements in MATLAB, and in the next section we'll look at writing some functions and look at trying to control the flow of logic in a MATLAB program.